API 510, Pressure Vessel Inspection Code, Chapter 8. Repair, alteration, and rerating of pressure vessels and pressure relieving devices. Here we brought the highlights of this chapter. There's a lot of information that should be treated as potential exam question. Repair and alteration shall be done as per ASME construction code. So that's ASME section 8, all repair and alteration. All welding and NDT procedures, QA manual, execution of the plan, inspection plan and repairs and materials shall be approved by inspector or engineer. Pressure relieving devices should be repaired as per approved QA manual according to API 576. If there is a carbon or alloy steel with carbon content over 0.35%, it should not be welded, so they are not used in pressure vessels with a carbon content of over 0.35%. And if it has a carbon content of over 0.30%, it needs preheating to avoid weld cracking. The preheat temperature shall be 300 degrees Fahrenheit or 150 degrees centigrade, covering at least 4 inch or 40 on each side of the weld joint, whichever is greater. So the preheat should be 4 inch or 40 from each side of the joint. Minimum taper is 3:1. So you are welding two plates with different thicknesses. It should be tapered to reduce the stress concentration for sudden change of shape, and that should be 3:1. That is the length of the taper is 3, and the difference in thickness change is 1 if you consider it as a triangle. Minimum corner radius should be 1 inch. So that's for patches that you do for repair, again to reduce the stress concentration, to smooth out any sudden changes in the shape of the patches. Authorization. So this is an important paragraph. You should expect a couple of questions from here. Inspector shall authorize all the repairs and alteration before the work commences by the repair organization. Now, however, for alterations, as per ASME Section 8, Division 1, for vessels up to 3,000 psi, and also for if the vessel is made according to ASME 8, Division 2, which is normally for vessels over 3,000 up to 10,000. So as we said, ASME 2 is more onerous than ASME 1. Engineer's approval is necessary. So for repair, you only need inspector's approval for a vessel made according to Division 1 of Section 8 Construction Code. But for Division 2 of Section 8, you need both the engineers and inspector's approval. Whereas for alteration, obviously you need both the inspector and engineer's approval. Okay, so this is a major difference between Division 2 and Division 1. Also, Division 2, the safety factor is 4 when designing the pressure vessel, whereas Division 1 is 3.5. So it's less onerous or less stricter. Now, Division 1 says up to 15 psi, up to 3,000 psi. That's the range. And Division 2 says up to 10,000 psi. So as you can see, it's more, but there can be overlap. So it depends on purchaser to define which one is it. It may be the vessel is less than 3,000 psi, and due to some criticality of the vessel, they want to go for a stricter code division, so they may still choose Division 2, even if it is less than 3,000. but normally the industry norm is over 3,000. You use division 2. Anyway, you have to use division 2 because division 1 is only applicable up to 3,000 psi. Okay. If the inspector is satisfied with the repair organization quality of work, and if the repair does not involve pressure tests. So there are two conditions here. One is the inspector's approval, and inspector is satisfied with repair organization work based on previous performance or whatever he decides. And the repair also does not involve pressure test, then no authorization is required on case-by-case basis. And in these cases, the inspector can pre-authorize the repair organization for routine repairs, provided no pressure test is involved. So this might be a potential exam question that the inspector can pre-authorize. Now remember here, the inspector authorizes and approves the repair here. Is the focal point, and approves the procedures, the manual, approves the NDT reports. The inspector would specify the hold points for repair activities. So different activities that is done for repair, the inspector would say, okay, this is the hold point I would like to see. And the hold point means the activity cannot go forward. The repair cannot go forward until the inspector checks and approves that step, so they can go to the next step. The inspector needs to approve all designated hold points before the repair team can continue the subsequent step. The inspector also approves the completion of repair. Once the repair is finished, he is satisfied with that, he or she, so he would approve the repair also. Prior to repair, all the proposed method of repair, such as welding, NDE, material selection, execution of the job, and design shall be approved. Shall be approved means it's normally the inspector. Repair of cracks and high stress concentration areas need engineer's approval. Now remember here that it also needs engineer's approval if there is a crack or high, because crack is the highest concentration is on the cracks. I mean, compared to other discontinuities, such as lamination, lack of fusion, porosity, or any other defect or discontinuity that might have. Cracks has the highest stress concentration because the crack is the sharpest of them all. It's like a knife cutting through. Design. Like for like part replacement and replacement of nozzles shall meet the original design code of construction requirement. Does not need engineer's approval. However, nozzle installation shall be approved by the engineer. So what it says is, as long as they go to according to the design code, original design code, and replace the parts or nozzles, it doesn't need engineer's approval. But installation of the nozzle, the manufacturing doesn't need engineer's approval, but the installation of the nozzle should be approved by the inspector, so that there is no undue stress from the piping from the nozzle on the vessel or vice versa. Material used for repair shall comply with code of construction. As you know, there should be a traceability of the material, the pressure containing parts, the plates, and also there should be a mill test report. If the inspector is in doubt about the material, you can do a PMI, positive material identification, to see that it's the right material. Base metal with carbon content. This is we already talked about. Again, it brought in this subchapter. 0.35% carbon content shall not be welded, and with carbon content more than 0.3%, need a preheat to avoid welding. So this is repeated twice. Be careful. This is anything repeated twice in the codes or recommended practices. There's a high possibility of question from here. Repair of defects shall be performed as per HAZME PCC2. Repair of pressure equipment and piping. Repair of cracks need approval of engineer who ensures that cracks would not propagate upon completion of repair. So if you want to repair a crack, normally you drill a hole at the tip of the crack to reduce the stress concentration, to reduce the sharpness of the crack, and then you normally remove the crack and by grinding it off, and then build up by weldment. But then the engineers need to be involved to make sure that the crack does not propagate after you completed the repair. Fillet welded patches would normally be applied to the external surface for easier on-stream inspection. Fillet patches shall have a rounded corner of minimum 1 inch radius with a weld joint efficiency of 0.45. Okay. So, and the distance between two of the fillet welded patches shall not be less than 4 square root of RT, where T is the vessel thickness, R is the inside radius of the vessel. So you have two fillet patches. There are two requirements here. The distance between these two should be greater than 4 square root of RT. R is the radius of the shell and T is the wall thickness of the shell. And this corners should be, radius should be minimum 1 inch to reduce the stress concentration. And this distance restriction is because they are not superimposed, the stress concentration here, okay? And the thickness of this weld, because the joint efficiency is 0.45, so the strength should be calculated based on that joint efficiency of 0.45. The required thickness of repair weld shall not be more than 50% of base metal. So if you're building up, you're grinding off some defects and then building up by weldment, then it should not be more than, the depth should not be more than 50% of the base metal. The strength of repair weldment should be at least equal to or greater than the strength of the base metal. So always the weld strength should be greater than the base metal, because you have some, already have, due to weld, you have some stress concentration here because there is a change of shape and also the ripples on the weld. And if it is less than the strength of the base metal, the repair weld thickness shall be adjusted accordingly. Now, how it is adjusted? For example, if the strength repair of the weld is 80% of the base metal, then the thickness of repair weld should be increased by 0.8 divided T divided 0.8. So the thickness of the weld should be 1.25 T. So the weld repair is increased by 25% when the strength is 80% of base metal. Okay, in this case, the increased thickness shall be tapered into 3:1 ratio minimum. So this is the same way when you use two plates with unequal thickness, different thicknesses, and you use a taper to 3:1. The triangle, as we said, 1 being the difference in thickness and 3 being the length of the triangle. The same is true when welding two plates or pipes of different thicknesses. Weld repair shall have at least 2 passes. So this is to make sure that if one pass is defective, so it doesn't suddenly burst or anything, it will at least, it is still the second pass. We assume that this is to be sound and it can hold on the pressure, or even if they cannot hold, then you would have less mode of failure, like you would have a leak at least, not a total failure. Welding and hot tapping. Welders and welding procedure shall be qualified as per section 9, and repair organization shall keep the records including WPS and WPQ. Welder performance qualification and welding procedure specification. The inspector shall ensure that a minimum preheat equipment requirement is met during welding. Preheat is an essential parameter. That means if a cooler preheat is applied, a new WPS need to be developed and approved by the engineer. So if it is in WPS, the preheat is mentioned, and you actually want to do a lower preheat, so that is an essential parameter. So that means a new PQR and a new WPS. Post-weld heat treatment can be substituted with a preheat of 300 degree Fahrenheit, 150 degree centigrade. It's not always the case. You cannot do it, but it is possible to do it. Maintain, and this preheat should be maintained 4 times the material weld thickness or 4 inch, whichever is greater on each side of the group. So remember, preheat 4 inch, 4T, post weld 2T or twice material thickness on each side of the groove or weld. The post-weld treatment for weld repair can be local or full circle 360 degree. So the code is very liberal on here. It says you can do a local or do a band of 360 degree on the weld. And it should be maintained within 2T or twice material thickness. For material group numbers P1, P3, P4 sheets, controlled deposition welding can substitute post-weld heat treatment. Remember that controlled deposition welding is when you do a pass and use the heat from previous pass as a preheat for the subsequent pass. Or half bit when you shave off half of the weld that you have done and then apply the other weld. So when notch toughness testing is required, Sharpie test, and you cannot do post-weld heat treatment for any reason. For example, you got a carbon steel stainless steel weld overlay and it's on a vessel, and if you do a post-weld, then after you might damage the stainless steel weld overlay, then you can do controlled deposition welding. And for that, you need to see section ASME section 8, division 1, parts UG 84 and UCS 66. Also, you can see table 8.1 for qualification of repair welding procedure specification. And also please note that the repair weld is qualified for thickness that is actually tested, the PQR tested, unless it's not like a welding procedure specification where the thickness test coupon that tested normally and is qualified half times of that up to a range of twice. So it is always the test coupon that tested for weld repair is the qualification range is up to that test coupon's thickness. CDW controlled deposition welding has 2 techniques: temper bead, when the heat from one pass is used as a preheat and interpass temperature for next pass, or half bead, when half of each pass is flushed out or grounded. The outgassing of shielded metal arc welding is done by keeping the weldment at 500 degree Fahrenheit plus minus 40 degree range for 2 hours. So for 2 hours, you keep it at that temperature if you're doing a shielded metal arc welding to outgas any hydrogen or any other gases to escape. This would help release any hydrogen accumulated in the weldment during welding. Baking of electrode is not required for H4 types of electrodes or low hydrogen if it is sealed. After flushing out or excavating the defect, empty or PT is carried out to ensure that the defect has been completely removed. If original weld was radiographed, the repair weld should also be radiographed as well. If it is not possible to radiograph the repair weld, then UT can substitute RT. If none of UT or RT is performed and alternative NDT technique is performed, then it shall be approved by the engineer and inspector, and the weld joint efficiency shall be accordingly reduced as per construction code. For example, if the UT or RT you cannot do RT, then they can ask for a deviation, asking to do UT instead for some reason, for safety reason. So still you have, because both are volumetric, you still have a joint efficiency of 1. Now, if you cannot do any one of them for any reason, such as access or it's not practical, and you do some other tests like, say, MT or PT, now the joint efficiency is normally 0.85. Then you don't do volumetric, you do surface examination by MT or PT, for example. So the joint efficiency should be reduced accordingly as per the construction code. Stress risers such as flows and notches could initiate a brittle fracture during pressure tests or in service. Hence, proper NDE techniques such as MT shall be considered to monitor the situation. So normally the crack happens at the surface because that's the highest stress. If you consider through the thickness of the material, the highest stress at the surface, so before fracture, the cracks appear at the surface. So might be detected by MT. Rerating. Any activity that changes vessel design parameters such as MD, minimum design metal temperature, or maximum allowable working pressure is called an alteration. Calculation leading to rerating can be performed by the manufacturer or owner user engineer applying vessel's construction code. That is straightforward. If a vessel is built pre-1999, then it can be related to current construction code, and there is a flow chart in figure 8.1 of ASME section 8. How you do it: for pre-1968 built vessel, the original safety factor of 4 or 5 for allowable stress shall be used. So pre-1968, the original safety factor of 4 and 5. And there is a so if something is built according to pre-1999 ASME construction code or any other construction code, then they brought this figure. This is a flow chart that tells you either you have to recertify it if you are doing a major, you're doing an alteration or a major repair. So you have to recertify the vessel according to original, or using the current construction code, how to do it. Upon approval or re-rating by the engineer or manufacturer, a re-rating nameplate shall be attached showing new MAWP and MDMT. So new nameplate, this is the only time when a new nameplate is used when you are re-rating the vessel. Okay. And then it should be approved by both the engineer and manufacturer, and the inspector upon approval would verify that that nameplate actually is being affixed. There are 4 annex. Annex A, code exemption. It tells you what sort of vessels are exempted, like valves, compressor, vessels with pressure less than 15 psi, moving pressure vessel like a truck on ship, direct fire, tubular heaters, piping. So they are exempted, and vessels with certain volume and pressure. And this is the figure that you see. And this is if it is an open book, they will tell you that, okay, we got a vessel, say 350 psi pressure, and then say, with this volume, say 3.5 cubic feet. Is it included or not? Or 2.5 obviously is included because beyond this. This is on this area. So as you see, this gray area are exempted. So if it's 300 psi and say 2 cubic feet, then it is exempted. Or if it's 600 psi, then 2 cubic feet not exempted, 1 cubic feet exempted. So you can see this would be give you the idea. It is also in ASME construction code, but this is the easiest way to go. Annex A 510. Inspector certification, this also you need to remember. Might say what is a prerequisite for inspector certification to attend the exam. So it's 1 year, an engineer with 1 year, a technician with 2 years, and a high school 3 years or no education 5 years experience in supervision of or design, repair, re-rating of the pressure vessel. Recertification every 3 years. So every 6 years there is a quiz. So this is about inspector certification. Annex B. Annex C, have a look at it. It shows how an inspection report should look like. You might you kind of find it very useful. Annex D, sample repair, alteration, or rating of pressure vessel. There are some forms here, normally includes information in Annex C plus fabrication and repair information such as post-valley treatment. Open book question may come asking which item is not normally included in repair and recourse. And you have to go to this annex and see which one is it and then tick that question.